Hello Colonet Africa online students, welcome to our further lesson. In this lesson we are going to look at the method of preparing of salts, and mostly we are going to tackle the preparation of the soluble salts, and for our examples we shall look at the preparation of zinc sulfate and copper sulfate. The methods chosen for the preparation of specific salts may depend on the solubility of the salt in water, and that's why we tackle the solubility first. Preparation of soluble salts. How is zinc sulfate prepared? Zinc sulfate is a soluble salt, so you're going to find that in order to prepare zinc sulfate, we normally have an action of an acid on metal, and once you react a metal and an acid, you get a salt and hydrogen gas. Remember in form 1, when we were preparing the hydrogen gas, we found that in the laboratory, you just react zinc metal with sulfuric acid. Measure about 20 centimeters cubed of dilute sulfuric acid and transfer it into a beaker. Then you add zinc powder, a little at a time as you stir with a glass rod. Continue adding zinc powder until it is in excess. Remember, you use zinc powder in excess to ensure that all the acid has reacted. Filter the solution and pour the filtrate into an evaporating dish. The filtrate is the solution bit and the residue is the excess zinc. Evaporate the filtrate to saturation. To find out if this point has been reached, dip a glass rod into the solution and hold it up into air to cool. If crystals form on the tip of the rod, the solution is ready to form crystals, and the heating can be stopped to allow the now saturated solution to cool and evaporate slowly. Metal reacts with acid to form salt and hydrogen gas. So a reaction between a metal and an acid, you get a salt and hydrogen gas as the product. Zinc reacts with dilute sulfuric acid to get salt, which is zinc sulfate, and hydrogen gas. We normally have an effervescence, and this effervescence, when this effervescence stops, then it means that all the acids, sulfuric acid has completely reacted with zinc powder. Zinc powder is preferred since it has high surface area, which increases the rate of reaction. Excess zinc is used to ensure all the acids react completely. The unreacted zinc is removed by filtration as the residue. This is the equation, and this is the chemical equation: zinc metal or the powder plus sulfuric acid to get zinc sulfate. It is in aqueous form, that means it is soluble in water, plus the hydrogen gas. You can test this hydrogen gas by introducing burning splint, and once you introduce a burning splint, it burns with a pop sound to ensure that, which is a test for hydrogen gas. The saturated salt solution is allowed to cool for zinc sulfate crystals to form. The process of obtaining crystals from a saturated solution by cooling is referred to as crystallization. Other salts that can be prepared by this method are magnesium sulfate, zinc chloride, and calcium chloride. These are the equations that are involved. We have magnesium plus nitric acid to get magnesium nitrate, which is soluble salt, plus hydrogen gas. Zinc plus hydrochloric acid to get zinc chloride plus hydrogen gas. Calcium, if you add hydrochloric acid, or you add it to hydrochloric acid, you get calcium chloride plus the hydrogen gas, and all those are soluble salts. The reaction of an acid and metal, as seen, is one of the methods that is used in the preparation of soluble salts. And let's look at how you prepare copper 2 sulfate solution or salt. Measure about 20 centimeters cubed of dilute sulfuric acid and pour it in a glass beaker. Warm the acid in the beaker. Using a spatula and a copper 2 oxide to the warm acid, a little at a time while stirring with a glass rod until no more oxide can dissolve. So in this case, you're adding copper 2 oxide, which is a base. You're adding a base to an acid. That means it is a neutralization reaction. Filter and collect the filtrate. Remember, you use excess of copper 2 acid to ensure that all the acid has been neutralized, because you're neutralizing an acid using a base. Transfer the filtrate to the evaporating basin. Evaporate the filtrate over a water bath to saturation. Stop heating and allow the saturated solution to cool to form crystals. Dry the crystals in between filter papers. The reaction between copper 2 oxide, which is a base, and an acid, which is dilute sulfuric 6 acid, produces a salt and water only, which means the resulting solution does not have any effect on a litmus paper. The reaction is called neutralization. Calcium oxide plus sulfuric 6 acid to form calcium sulfate plus water. That's the chemical equation. Excess copper 2 oxide is used to ensure all the acid is reacted. Warming speed up the reaction or the rate of reaction, and evaporation of the filtrate is carried out over a water bath to ensure slow evaporation, hence formation of large crystals. Otherwise, the crystals will be small. Other salts that can be prepared in a similar manner are red 2 nitrate, magnesium sulfate, and calcium chloride. These are the equations that are involved. A base, which is red oxide plus nitric acid to form red nitrate plus H2O. Red nitrate is a soluble salt. Magnesium oxide plus sulfuric 6 acid to give us magnesium sulfate, which is soluble salt, plus water. Calcium oxide plus HCl to give us calcium chloride plus H2O. And all these are soluble salts. The reaction of acid and insoluble base is another method of preparation of salts, which is ideal for the preparation of soluble salts. That brings us to the end of our fourth lesson. In this topic of salts, you have 8 questions to answer in this lesson of method of preparing salts. Make sure that you answer the questions, don't copy. Integrity is paramount, and hence once you're done, you can use the word document and mark for yourself. All the best. Let's meet in the next lesson, that is lesson 5 of the topic of salts. Bye and have a good one.